Okay, we're in section 6 of the notes. It's the method of cylindrical shells. Basically, it's a visualization problem. I'll certainly read through this. It's going to be a brief section. Again, part of this is just a review of what you've done in Math 121. I'll certainly go to an example, and then we'll do some more examples in the section on examples. All right, it's a very brief section, though. It's really not much to say about this. All right. So, and then you're expected to reinforce it by doing homework, by the way. So let me go back to the whiteboard, and we'll start it with the lecture portion. And again, we're in section 6 of the notes. Give me a second to get to the whiteboard. I think I'm doing okay here. Okay, so let's start the beginning. And the beginning is just simply understanding what a cylindrical shell is. And again, I lifted this out of a textbook. The reason being is it's not a bad looking image. However, you may look at it and say, I have no idea what it's showing me. It's showing you something that if it's not understood, it's going to be really tough to do the cylindrical method. So let's take a look at this. And I want to point out this material was covered in Math 121, or at least it should have been, but it's going to be briefly reviewed here. All right. So I'm going to say it's basically, do you understand how to apply integration in a reasonable way? All right. So I'm going to say you should be familiar with that disk method we talked about. All right. And we've done a lot of those things, rotating the things over here. Now, of course, they're going to move on to another method that's related to the disk method, but this is called cylindrical shells. So what we'd like you to do is be able to visualize what they mean by a cylindrical shell. And this is a good image over here. And, you know, kind of looking at it, I want to point out there's an object here that looks like a shell to me. Now, a shell to me looks like a can. What they do is they cut it and then they fold it flat. So if they do that, you know, I'm still seeing that circumference part there. You know, so what's that going to be? Well, it's going to be 2 pi times the radius. Well, what's the radius in this case over here? X. So the circumference is 2 pi x. Fairly reasonable. What's the width of the object? It's going to be dx. All right. And that's the width of it. All right. But that's what we need to know, the height of it. And the height of it is just simply the value of f of x. That's all it is. So what's the volume of that box? Well, the volume of this box over here, let's write that down for you with a black pen here, is I take these 3 dimensions and multiply them together. So what do you get? 2 pi x times f of x times delta x, right? Fairly simple. Here comes the problem. You'll be able to visualize that with the problem. So let's take a look at an example they're giving us. And the example they're giving us over here is, you know, find the volume solid, obtain the region. Yeah, it looks like it's sort of like a familiar problem. I think we've done this one before. But anyway, let's take a look. And I'm going to visualize it. All right, so what do? First thing I do, I want to visualize the curves. And again, what curve's talking about? Y equals x. Fairly simple. That looks like this over here. Again, there's no need for really great detail in this over here. The other curve is y equals x squared. I'll put this over here. And again, I'm not saying it's a great picture, but I got my points over here, 1, 1. And I got a point over here, 0, 0. And I definitely see a region that's being enclosed here. And this is the region. What are they going to do with the region? I don't know. I have to read it. What do they want to do with this region? Oh, they want to rotate this thing about the y-axis. So it's going to rotate like this, about the y-axis. This is y-axis, and this is x. So what I'm going to do, it's the same story. I'm going to visualize a rectangle. All right. So when I rotate that rectangle about the y-axis, I'm going to get a shell. That's what I'm going to get when I rotate that around. So then what I do with the shell, I cut it. And when I cut it, I fold it flat into a box-shaped object like this. By the way, I know this is crude. We're not expecting anything beyond that. So let's talk about this. It's dx. The thickness of this thing is dx. That's still going to be dx over here. All right. What's the circumference of this thing? This is going to be the circumference around. It's going to be 2 pi. Well, it corresponds to an x. That's its radius. So 2 pi x. Here comes my problem. What's the height of this object? Should be simple. And why is that? The height is just upper minus lower. What's the upper curve? Y equals x. What's the lower curve? Y equals x squared. What's the height of that thing? X minus x squared, upper minus lower. I think I can write my integration down now, and my limits integration are going to be from 0 to 1. along the x's, 2 pi x, that's this dimension, times this dimension, it's a box, by the way, times dx. All right, let's go to 10 and integrate it. We'll get the answer. It's gonna be really brief, not much to say about this. 2 pi, we have a key to look at. X times x is x squared minus x cubed dx. Let's do our integration. What do we get? 2 pi. Oh boy, what do we got to do over here? X cubed over 3 minus x 4 over 4. Integration 0 to 1. Right, I'm not going to do fast for you. What do you get over here? 2 pi. Plug in 1. That's 1/3 minus 1/4 minus the lower limit, which is 2 pi. Well, that's nice. It just value to 0. So we get 2 pi. I need to add those two together. 12's common denominator. And 4 minus 3 is 1. So what do you get over here? Pi over 6. Let's look at the key and see how we did. Wow, pi over 6. By the way, the worker's down there. It's down there for a reason. You may look at my chicken scratch and say, gee, it's hard to read that or understand what you're doing. What's the problem, though? Setting up the integration. That's the problem. Okay, next up is going to be me going to, oh, by the way, this is also being done by disk over here. You can do that if you want. I don't recommend it. Let me see if they do say to do that. Find the volume solid obtained by retained. Yeah, cylindrical shells. I recommend it. Now, someone says, why did you do disk? I was shocked when I went to a conference years ago for high school students, and the AP counselor said to me that they don't teach their students the shell method. They say all problems are done by disk. And I said, well, shell sometimes makes problems easier. We said, yeah, that may be true, but the bottom line in the AP exams, they want everything by disk or washer method. I got to be honest with you, though. You can do that. You get the same answer if you want. If you need to see me do this, please ask, and I'll be more than happy to do it for you. All right. But this is from a prior section. Next up, examples, and we'll do that next.